Okay, so the last things I will talk is hydraulic and pneumatics, and I'm not going to go through any theory. I just want to give you an overall flavor of what hydraulic actuation is all about and pneumatic actuation is all about. So this shows a very simple hydraulic system. There is a tank, usually an oil tank. You need to, well, the tank will have oil and oil will have some particles which you need to filter. That's what the filter is doing. You need to pump that because the way hydraulics work is high pressure oil. So you need a pump. Sometimes the pressure might be so high that you might damage the system. So there's a regulator which limits the pressure produced by the system to some nominal value. And there's a valve. This is a very important component, basically controls how this piston, which is connected to your output shaft, will move. So these valves control how hydraulic fluid will flow through your cylinder. Okay, so let's get into the details. Hydraulic fluid, that's usually some oil. The pressure is 1,000 to 3,000 psi. So just to give you a context, atmospheric pressure is 14.7 psi. So this is like, I guess, at least 100 times more powerful than ambient pressure. So, you know, you can get crushed with 1,000, 3,000 psi pressure. It's very high pressure. Now, the fluids which you use have to have certain properties, okay, lubrication, corrosion, and need to be incompressible. Okay, this is a problem which will come in the pneumatic system. Air is compressible. Compressibility introduces a host of other problems which are not so much in a hydraulic system. And this is one of the main reasons why people choose a hydraulic system, because it's incompressible. Fluids are not compressible as much as air is. The pressure regulator, as I said, is used to regulate the pressure. It usually consists of some spring so that when the pressure produced by the oil exceeds a certain threshold, the spring basically lets some of the steam, or in this case, sorry, the oil, to go away, and that basically return to the tank, which means that the pressure decreases. Okay. This is called a spring ball element. It's very, very common in such systems. Hydraulic pump. As I said, the pump is supposed to take the ambient oil at ambient conditions, pump it to high pressure, and then the high pressure can do work, right? So there are a couple of pumps, gear pumps. You can see it as gears. Vane pump. It sort of depends on how this shaft moves. So its motion, it has a specific motion which sort of compresses the oil which is flowing here. It's a bit complicated, but you know that does its job. There's a piston pump, which basically is traditional piston. So if you put something inside a cylinder and you compress it, then you'll really have a high pressure fluid. That's what is used here. Just some idea about the cost, the pressure, and this is the type of displacement, fixed variable. You don't have to know so much detail, but I think this is important. You get low pressure with a gear, but highest pressure with a piston pump. The cost also is a factor. If you run low pressure, you pay less. High pressure, then you'd have to pay much higher. But 6,000 psi is a lot of pressure. Okay, the valves. Okay, where do the valves go? I think that's, you see the valve goes here. It basically controls how the hydraulic oil will flow in through this piston, and that piston is basically the thing which is connected to the output shaft. Okay, so you can see that there's a P, there's A, T, and B. Let's see what those things are. Here are a couple of types, but let's just look at this one, the one which I showed you earlier. So the inlet and outlet connections are called ports. So all these things, P, T, A, B, are called ports. They're denoted by X cross Y, where X is the number of ports and Y is the number of positions. So here we have a 4/3 valve. So the 4 means the ports. So you can see there are 4 ports. And there are 3 positions. What are the 3 positions? Well, one position is when P is connected to T, that's position 1. One is when P is connected to A and T is connected to B, that's position 2. And then we have P connected to B and A connected to T, that's position 3. Okay. Why do you have these 3 positions? Well, this is how you control the piston. Remember, this is connected to a piston. So if you connect P to T, it sort of bypasses. So this is connected here, right? So if you connect P to T, that bypasses the cylinder. You can just let the fluid go back to the tank. If you want to pressurize A, just draw a better figure here. Okay, this is B. Now, remember that pressurizing A will mean that you'll have high pressure on the top and low pressure down, which means that the piston will move down. Okay, so A is pressurized, B vented to the tank, so this is connected to the tank, which means that the piston will move down. If you want it to work in the reverse, then what you'll do is you'll pressurize B. So P will be connected to B here. So there'll be high pressure in the bottom and low pressure on the top, which means that the piston will move up. Okay, so that's how you make this thing move. A simple idea, that is just using these valves in the right way. Now, this is assumes that you're just going on and off with the valve, but you could also have a way in which you control so that there is controlled flow of pressure, so you can generate a certain speed with this output shaft. Okay, so examples of valves: check valve, popper valve. This is a spool valve. Okay, there's a pilot valve. A pilot valve is supposed to feed the spool valve, but I don't want to get too much into details of this. But remember, all they're doing is basically controlling the ports, and then the different ways in which you do that. This one uses a ball. I think the difference is being that one of them works with gravity, one doesn't work with gravity. Yeah, that's pretty much what the difference is. And the spool valve doesn't have any springs, but I think it's powered by an external. It should probably be powered by some electric motor or something like that. Yeah, so they're controlled by solenoids. The solenoid is something we've seen before. Solenoids can basically go on and off. But if you don't want just on and off, then you want a servo valve, which basically controls how much pressure and force you can apply. Okay, finally, actuators. You can have single acting actuators. These are not there. So these are one way, that is, you can power them and you want them to move. So this way, if you power them by sending high pressure oil, they'll move to the left. But if you want them to move to the right, then you put a spring on the left and it will put it back. A double acting one was shown earlier. You pressurize it. Actually, I did a mistake here. This is wrong. Here you can see that there is A here, which means that it is pressurized here. So the oil will come here. So it will move to the right by default, but you need a spring on the right side so it can spring back. A double acting one will have valves on both sides, and you can pressurize either way. So you can go left, right, or right, left. Okay, here are some examples of things powered by hydraulics. Really, you want to go with hydraulics when the load is going to be substantial. You do not want to use them in things like small appliances like dishwasher, microwave. Just don't want to use them because they just take so much space. And then there is this. Okay, so a pneumatic system looks like this. It's very similar to a hydraulic system. Let's see what goes in the filter. You need to remove so air is going in. You need to clear out unnecessary particles in the air because it's going to damage your system. You need to compress the air, okay, because you need high pressure air. You treat air after that. Okay, the filtering is different from air treatment. I think it removes, for example, the moisture. Then there's a reservoir, pressure regulator, which ensures that the pressure doesn't exceed the rated pressure. There's a control valve very similar to a hydraulic system, and then you have the cylinder. So the system looks essentially similar to that of a hydraulic system with a few differences. One of the differences, some of the differences are you get low pressure. You only get 70 to 150 psi. There's a compressor instead of a pump, like because you only have compressed air. You need air treatment. You don't need that for a hydraulic system. And finally, this is probably the biggest advantage of the pneumatic system. Here, air is exhausted to the atmosphere, you don't really need to have a tank to hold the air because air is available free, but for hydraulics, you need a tank and you need to return the oil back to the tank. So this is the last part in the course. We're done.